Welcome to Mission Control. I am your host, and today I'm stepping in as your flight director. We are going to treat your Cambridge Afrikaans AS Level Paper 2 like a high-stakes space flight. And you? Well, you are the pilot in command. For this simulation, we're locking in entirely on subject code 8679, specifically zeroing in on a crucial payload known as building vocabulary. Okay, let's set the scene. Imagine you're sitting right here in Mission Control. The pressure is on, the exam clock is relentlessly ticking down, and every single mark you write is a critical maneuver that decides whether you reach optimal orbit or burn up on re-entry. We have to realize right out of the gate that your vocabulary isn't just some dusty list of words you memorized, it is literally the navigational software that runs your entire exam system. To really grasp the gravity of this mission, we need to talk about the telemetry data. Building your Afrikaans vocabulary accounts for a massive 15% of your total marks in Paper 2. Now, it's kind of funny, honestly, how deceptive that 15% can seem to an untrained pilot. You might look at it and think, hey, I'll just ignore that and focus on the other 85%, no big deal, right? Well, let me introduce you to two simulation pilots we've been tracking on the radar, Pilot Alex and Pilot Sam. Pilot Alex treats that 15% like it's just pure rote memorization. Alex ends up overcomplicating data calculations, burning way too much exam time and fuel trying to force complex words into places they just don't belong. On the other hand, we have Pilot Sam. Sam ignores the structural boundary constraints entirely, risking a complete systemic breakdown. Why? Because without that core vocabulary, you literally cannot access the rest of the paper. That 15%, it's not optional. It's your ignition sequence. So, here is our flight plan for today's explainer. We'll initiate with the 15% mission, transition into telemetry and technical methodology, scan for avoiding critical exam debris, and finally, lock in on mastering the final touchdown. Initiating Phase 1. Let's establish the foundational flight principles required to master this 15% payload. Cambridge requires you to absolutely master 4 specific cognitive domains. You have to prove that you have a connected, conceptual understanding that can be transferred to completely unfamiliar contexts. Let's look back at Pilot Alex in our simulation for a second. Alex has vast knowledge and understanding. Alex practically memorized the entire dictionary. But the second Alex's system is faced with a totally unfamiliar text, it just crashes. Why does that happen? Because Alex lacks the analysis and evaluation thrusters. The examiners are explicitly testing whether you can take a piece of vocabulary you know, drop it into a completely alien scenario, and actually use it accurately. Transferability is the golden ticket to clearing orbit. But this raises a really crucial question for us here at Mission Control. Why do so many candidates experience systemic breakdowns when attempting multi-stage analysis? It is by far the most common failure point we track on the radar. Think about it. When you have to identify a word's meaning, then explain its function in a sentence, and then evaluate why the author chose it. That is multi-stage. Our other pilot, Sam, usually stalls out right at this exact moment. Sam gives a one-word answer when a 3-stage sequence is required. The system simply shuts down because there's no technical framework to process the data. Moving into Phase 2. The answer to systemic breakdowns lies in our telemetry phase, where we map out a strict technical methodology. The absolute secret weapon here is the method mark strategy. This means the systematic process of deconstructing the problem is just as critical as the final answer you land on. Think of method marks as your telemetry breadcrumbs. The Cambridge examiners want to see your working. They want to see exactly how you analyze the vocabulary in context. Even if your final translation or synonym isn't 100% perfect, if you have demonstrated systematic analysis and extracted the right contextual data from the stimulus text, you secure partial payload marks. You are actively rewarded for your process, not just perfection. This 6-step procedure is essentially your pre-flight checklist for navigating complex texts. Step 1. Deconstruct the question parameters. Are they asking for a synonym, an antonym, or an explanation of effect? Step 2. Extract data from the stimulus material. Please don't just guess. Use the surrounding sentences as your navigation beacons. For Step 3, you select your analytical framework. Then use that to execute your answer with clear notation in Step 4. Step 5, verify. Does this actually make logical sense in Afrikaans? And finally, Step 6, present your findings with the correct terminology. Phase 3, avoiding critical exam debris. Now, flight director pausing the simulation for just a second. Before we fire the secondary boosters to secure maximum marks, you need to optimize your flight path. Hit pause, subscribe to Ace the Exams at Ace the Exams right now, and turn on all notifications. Seriously, lock it in. Okay, simulation resuming. Let's navigate this debris field. We are picking up a massive warning directly from the principal examiner reports. They are emphasizing that generic answers are the absolute fastest way to lose altitude. The examiners are literally giving us the black box data from thousands of crashed exams. Generic answers not specific to the question context. We see crews encounter this critical roadblock mid-paragraph all the time, right where their evidence links fail. So I am overriding the console here. We are injecting the Peel structural template to save your trajectory. Point, evidence, explanation, link. If a word means bright generally, but in the text it describes a highly intelligent person, writing shining is a critical system failure. You must use the Peel template to link your vocabulary definition to the exact scenario on your dashboard. Let's break down the top 3 fatal errors on the radar. Notice how heavily examiners penalize pilots who drop proper formatting conventions, like headings and annotations. It's honestly shocking how many brilliant candidates lose easy marks simply because their formatting falls below compliance standards. They write this massive, blocky paragraph instead of breaking it down logically, or they forget to use the correct terminology. Listen, proper presentation isn't just about making it look pretty. It's aerodynamics. It's about making your logic perfectly readable to the human examiner grading your paper. All right, it's time for a live interactive viewer radar challenge. We call this debris detection. Imagine a 60-second visual countdown clock running on the main console right now. Your objective is to locate the hidden core variable. Compare the system failure of a generic answer on the left to the optimized flight path on the right. Look closely at that left side. Notice how the student just copy-pasted the dictionary definition? That's our pilot Alex again, burning fuel without any forward momentum. Now, scan the right side. The optimized trajectory pulls evidence directly from the text, explains the word-specific nuance in that exact sentence, and ties it directly back to the question. That right there is how you bypass the debris field entirely. Context is your deflector shield. Phase 4. Mastering the final touchdown. With the turbulence cleared, let's initiate our final descent. Top scoring candidates execute this rigorous deconstruct, solve, and evaluate sequence. This builds all the way up to questioning assumptions and making highly justified recommendations. You don't just solve the problem, you have to evaluate your own solution. Step 4 here, checking for reasonableness, is your anti-stall mechanism. Ask yourself, does the Afrikaans sentence I just analyzed actually make sense in the real world? If you've concluded a word means something that totally contradicts the entire tone of the passage, your system is failing. Course correct immediately and justify every single claim with hard text evidence. When a question demands comparative analysis, you must execute all 4 of these parameters flawlessly. You have to explicitly use comparative connectives to lock in your evidence. If you are comparing how 2 different Afrikaans texts use vocabulary to create tone, you can't just talk about text A in isolation and then text B. You have to bridge them. You must use words like in teenstelling met, meaning in contrast to, or gelijk soortig aan, meaning similar to. You identify similarities and differences, link them up, justify with quotes, and evaluate their relative impact. Consider this your absolute blueprint for a flawless touchdown. The ultimate takeaway here is that vocabulary at the AS level is not just about memorization. It is about the systematic execution of these professional skills. I'm looking at the monitors now, and both of our simulation pilots, Alex and Sam, have successfully recalibrated their instruments. They are confirming a successful full-mark touchdown sequence. They finally realized that the 15% vocabulary payload is unlocked through method marks, context-specific application, and structural frameworks like Peel. They aren't guessing anymore. They are engineering their answers. So, are you ready to distill all of this into your own pre-flight question scan checklist? Are you ready to practice these past paper maneuvers and guarantee your next exam mission is a complete success? Treating your paper like a highly engineered flight system is exactly what separates the average candidate from the elite. Thank you for joining me in Mission Control today for this simulation. To keep your trajectory totally optimized, subscribe to Ace the Exams at Ace the Exams right now, enable that notification bell, and drop a comment below sharing your subject and tier. Let me leave you with this final thought. If your Afrikaans vocabulary is the navigational software of your exam, when was the last time you ran a system update? Stay focused, trust your telemetry, and I'll see you in the next explainer.